Lignin is an important value chain for going for a sustainable society. It can be used to replace fossil-based products.
LignoCity is a unique testbed in the world. We can produce lignin from different black licorice that comes from different paper mills, and we can scale it up from only a few grams up to tons. Lignin in one sentence is the glue in wood, but you can extract it in the process we do here in LignoCity. And instead of burning it in the paper mill, we can create a higher value with evaluating the lignin into different products. It can be in asphalt, it can be made carbon fiber out of it, and it can be made bioplastic and many other applications. The testbed is located as a neighbor to Nordic paper, where the black liquor comes from that we produce lignin out of.
Within the testbed LignoCity, you also get contact with the research institute RISE. We can help companies that are interested in the lignin value chains, from the raw material lignin to the end products.
So here at RISE we have resources to work on the lignin that produce in LignoCity. We work on the different applications such as thermoplastics, thermosets, chemicals and fuels from lignin. So in this lab we make lignin-based carbon fiber and use it in different applications. For example, in this car you can see the roof is a lignin-based carbon fiber composite that the carbon fiber were made here in this lab. Also this car has a lithium-ion battery that in this battery also we use lignin-based carbon fibers.
In LignoCity, we want to welcome small and medium-sized enterprises that we can help to take the leap from idea to market in small and safe steps, which reduces the risk to scale up.
Our time here at RISE was a key in our development. It helped us to have our product ready for the market, and now we are moving on and starting our demo plant unit outside Stockholm, where we will produce 2,000 tons per year of our material Renan. This is one of the end applications of what we do at Rencom, using lignin to make plastic bags. The name of it is Renan, and we can mix it with bioplastics or fossil-based plastics, depending on the applications you want to do with it.
Region Värmland is strong in bioeconomy, partly because we have a lot of forests here and skills in how to create different applications out of the wood, but we want to grow even better and bigger on the bioeconomy, and lignin is one track. Here we have space for new possibilities with conference room, facilities and laboratory.
Hi, and very welcome to today's webinar, and welcome back to you who have been in the previous webinars. For you who haven't been, try to visit our webpage where you can find all the recorded events from before. And with that said, we also record today's event, and you will be able to find it on our page LignoCity in a few days. So today we will present Agnes Verin, professor from Karlstads University, and after him we have two presentations of master theses that have been made in our project. My name is Maria Almholt, and I work as project manager and business developer at RISE testbed LignoCity in Bäckhammar. And we plan to organize also in the future more events. So if you have suggestions on what you want us to present in the future, take the opportunity to write down your suggestions in the chat. And in the chat is also where we want you to ask questions to the speakers today. And for the best experience of today's event, we ask you to use the speaker view, and to change view in Zoom you go to the upper right corner on your screen, and there you find the view options. And the chat format you find on the bottom of your screen. And the LignoCity project is a collaboration project. And we have very ambitious goals to spread knowledge about lignin, as we do here today. And one important work in the project is also to help small and medium-sized companies or idea bearers who do not yet have a company to reach out to the market with their ideas in bioeconomy, preferably with a direct connection to lignin. And we want to do this in small steps, as resource efficient as possible, and with the help of the network that we have access to here in Värmland region and in the project. So it is thanks to LignoCity that we are gathered here today. And the project is a collaboration project between the parties RISE, Kristinehamn Municipality, Paper Province, Karlstads University, and also Nordic Paper and Rencom, who now have changed a name into Lignin Industries. So the start of the project took place the summer of 2018, and it will run until the end of this year. This project is financed with the help of the EU Structural Funds program and by the project partners and the Värmland region. At the LignoCity testbed, we produce lignin from black liquor, and lignin can be refined and used in different applications to replace fossil-based materials. And with that said, I would like to present Agnes Ferrin from Karlstads University, and we are very keen on listening to your presentations. Hi, Agnes, how are you?
I'm fine, thank you. Good afternoon.
Good afternoon. And please tell very short, who are you?
Yes, I'm Agnes Ferrin. I joined Karlstads University last autumn primarily as a research leader for Pro2B, which I will introduce to you shortly. You see the first slide here.
Great. We look forward to listen to your presentation, and all the questions, please type them in the chat and we will take them afterwards. Please, Agnes, go ahead.
Yes, you're welcome. So this will be an introduction to a large effort which we have at Karlstads University together with external partners in collaboration. We work in the circular bioeconomy, and Pro2B means processes and products for a circular bioeconomy. And to highlight a few things in bullet points, we work with process and materials research. And in these areas, I will not have time to go through. I will just give you a short highlight of a few, but primarily we work in linking forest-based value chains. That is the key. So we are about 40 plus researchers, students and postdocs. We work in close collaboration with, for example, Region Värmland in the Academy for Smart Specialization with the focus on forest-based sector. We work closely with other partners also. And one new partner where we are increasing collaboration is the Tree Search National Research Platform. And we work with research and education. And very recently, we have submitted a large number of different bigger research proposals, which aims both for research and educational development. And more are to come also on that side. So I will talk a little bit on valorization of process side streams, separation processes, sustainable wood construction, and a little bit also on tree search. The Academy for Smart Specialization, you have probably heard about. It is a collaboration between Region Värmland and Karlstads University. It is now going into its a new phase. A new strategy is being formed as we speak for the coming years. So 2020 was extended to include also 2021, and now the aim is a new strategy for the coming years, 21 to 27, in relation actually to the new EU Horizon Europe program also. So the same time span. So it is a close collaboration between the region and the academy as a platform for further growth. We at Pro2B Research and Educational Platform, we realized that we needed to sit down and point out the coming goals for the further development of the research area. So we used a model called the Grants for Goal, or Medel för mål in Swedish. And we have now workshopped this internally at Karlstads University, and we'll come to, for example, a new vision for the research environment. We shape the circular bio-based future. And we see, and I will come now to the first example here. We see, for example, two major trends in forest-based industry. One is digitalization, and the other one is biorefineries. And those two trends told us that we should start to engage in also in collaboration with the pharmaceutical sector, because digital tools and separation processes are large and new trends also in that sector. So we started now a collaboration with analytical chemists at Karlstads University, and a coming, hopefully, large project will be part of Pro2B, and this has to do with the digitalization that is the major trend in the forest sector, thanks to, for example, highlighted by a new MISTRA project program since a couple of years back. And we also know that there is a major trend in biorefineries across Europe. This shows current ones or planned ones in the chemical pulping, based on chemical pulping. This in paper mill-based biorefineries. But even more interesting, maybe the emerging biorefineries in completely new, using completely new processes, aiming, for example, in batteries or cosmetics or things that are not, you could say, conventional products or processes. So one thing here is to combine digital tools with advanced separation science processes. Learning from another parallel sector, the pharma sector, and making use of the best of both worlds, and going back and forth between the two industry sectors. So looking forward to this particular project coming up. And I go on with another couple of slides on tree search. And this is a national collaboration platform for research, research infrastructure, and educational. And now Karlstads University is a full member of that. We collaborated on education before. And with the full membership comes also the more easy access to very interesting research infrastructure down in Lund called Max4, with a specific beamline aimed specifically for wood and fiber composite materials. So wide angle and a lot of tomography possibilities to really pinpoint the hierarchical structure of wood and fiber-based materials down to very, very small sizes, so that we can learn how to further develop materials and processes. Another very interesting, you could call it a trend, is now that a lot of public funding and interest from industry companies swings over a little bit from the material research focus that has been the major thing, right, for a number of years, to actually to process technology, because industry and public finances, such as Vinnova in this case, have realized that this is also needed. So you need to have educated people who have researched and going out into industry, knowing much more about bleaching chemistry or lignin chemistry or so. And now we look forward to 12 to 13 new PhD projects in the area of process technologies in pulp and paper, such as the chemical recovery cycle, the fiber line, and paper technology. And this is coming shortly now in June. It will be evaluated and decided. So we are involved in 2 projects. I will not have time to go through this, but one is collaboration with SCA and Holmen and KTH, and the other one is a postdoc together with a coating company and Holmen. So we're right in the middle of the forest-based value chains, and this has led us into now a current proposal which we are preparing to send in to the Swedish Energy Agency. This is a collaboration with Linnaeus University and a lot of other partners. And we will work in the value chains around the forestry, the energy wood, the pulp and paper, the wooden products, and increase the competence in the areas. And a center of excellence such as this is a 5-year effort with a possibility to extend to another 5 years. And the goal can be worded in a way that it should contribute significantly to the energy and climate policy goals of Sweden. And we will have PhD projects, postdoc projects, meritization for junior researchers, and a lot of dissemination and really competence development. So looking forward to that also. Now, a couple of projects that are ongoing and looking for future possibilities. My colleagues, Maria Sandberg and also her colleague, Karin Granström, works with biosludge and using the sludge in a new way to produce bioplastics raw materials and also gases that can be used. And one side stream goes into a new process or a sub-process, and that process creates another side stream. So then you can cascade the different processes in a way that produces new ways for coming biorefineries. So one thing that they have now used is to make the bacteria really to grow in this soup and produce in the end bioplastics that have been test molded like this. So we're looking forward to a continuation of this. Another short example of current projects is high performance rails or cross ties. And it's so that there is now factories for CLT, which is cross laminated timber, but that production creates some side streams, some waste it's called here. But now it becomes a perfect new raw material for cross ties or rails, so that you can take these materials and produce new beams, which are tested with good performance, as you see here, as indicated here at least. And towards the end here of this short mixture, I will of different activities and coming activities of the Pro2B area. I'm also supervising Zulfikar Keskin, who is doing his master work in a collaboration with LignoDemo at Rice and Karlstads University. So he is not done yet with his project. He's doing the last things in the lab and writing his report. So perhaps a coming webinar will be by him. But he is using LignoBoost Lignin, blending with a oil paint, and see how that can help increase the UV stability of the paint and save the wood that is being painted. So with that, I close this one and wait for your questions or comments. Thank you.
Thank you, Agne. What an amount of interesting projects that's ongoing in Karlstad. And as you said, the collaboration with Soluble, we look forward to see the result, how he has been mixing lignin into paint. And if we are interested to follow any of these projects you have presented, where can we do that? Is it any social media, or is it any webpage we can visit?
Yes, a lot of the material is being communicated, of course, through the normal sources. But it is also so that so many things are happening right now that we don't have time even to put it on social media. So please, if you have any questions, forward them to me or any one of my colleagues who you've seen their names on some of the slides. Yeah, hope to be more proficient and more proactive in the coming months. But yeah, it has been a priority for me to really get going with new research proposals, and then we'll go from there. Thank you.
That's great. And to find all contact details, we will visit cow.se, I assume. Is that correct?
That's correct.
That's
you
correct.
can search for Pro2B.
Then we will do so. Thank you very much, Agne. And if you want to type your mail address in the chat, then people also can directly contact you, I assume, and be directed to the right person.
Yes.
Thank you. And if there are any more questions coming in, we can also take them at the end. So for now, thank you so much for your presentation, Agne. And one of the activities within LignoCity has been to start master theses, and two of them we are going to listen to the result from today. And we have Nicola and Luan presenting their master thesis first. So how are you?
Hello, we're good.
Hi, very good. Good. So what are you studying and where?
So we are two students from Lunds University. Yep. Sorry, can we share the screen so we can we can start the presentation?
You can share the screen, please do so. And you are from Lunds University, correct?
Yes, exactly. My name is Nicola.
And my name is Luan.
And we are two students from Lunds University. And currently we're working on our master thesis. As you can see the title right here.
Soon here is coming the presentation.
Yes,
Yeah.
now it's working.
Presentation mode. Yeah, please go ahead.
Yes, exactly. So we're writing our master thesis about lignin in asphalt binders. And we did this work with help of Per Tillgren at the laboratory and Paitim Soleimani as our supervisor as LDH. But our work has not been reviewed by the university yet, and we're still working on it. But we decided that we could present the observations that we've made so far.
So the reason to why we have chosen to write our master thesis about lignin is that bio-based binders have recently begun to be tested and used in small extent, which aims to replace bitumen. The advantage of bio-based binders is that their production is circular, to contrast to bitumen, which made from fossil raw materials. So if we want to use lignin as substitute for bitumen, it must show similar mechanical properties. Two measuring instruments, namely dynamic shear-rheometer and rotational viscometer, which measures the elastic and viscous properties of material, have been used in this study. For the test, we use a reference sample with bitumen with a penetration index 70-100 and mixtures with two different types of lignin, lignin 1 and lignin 2, mixed with bitumen. The content of lignin has been varied to assess the influence of lignin on the elastic and viscous properties. So the DSR measurements provided us the results for properties as rotting resistance and low temperature properties. Bitumen is a compromise product, so we get higher rotting resistance and at the expense of the low temperature properties. Yes. So, to determine the viscosity at various temperatures, the RFB measurements were conducted. High viscosity makes it harder to lay out asphalt. You can see an example from high viscosity material in daily life, such as syrup or honey, and an example for low viscosity, such as water.
And let's take a look at the results. The blue stack represents the reference sample with bitumen, and it's called 70-100 because of the penetration index. And the orange and green stacks show the results for mixtures with lignin 1, L1, and lignin 2, L2. So when you add up the lignin T high, as you can see, increases, which means that we have to go up to a higher temperature to get the same rating. And rating, you can see to the right what it means for a pavement. So the results showed that the mixtures containing lignin enhanced the rotting resistance as the content of lignin was increased. And that means that with lignin in asphalt binder, we can achieve less rotting, which is a positive development. However, asphalt binder is a compromise product. So the question is, what would happen if we would go from high to lower temperatures? As you can see, the low temperature cracking resistance was decreased for the samples containing lignin. That means that you have the same thermal cracking at higher temperatures. And this is the negative development that can lead to thermal cracking on asphalt pavements. And furthermore, the results from RVB measurements showed that an increase of lignin content in bitumen increases the viscosity. So that means in practice that we need to higher the temperature in order to make the asphalt mass manageable. And finally, our results were compared with results from some other earlier studies. You see the source right there. And there were studies using granite filler. And in this regard, mixtures with granite filler showed similar elastic and viscous properties as lignin 1 and lignin 2. So that means that rotting resistance was better, but at the expense of low temperature properties. However, the advantage of lignin in asphalt against the granite filler could be that the impairment of low temperature properties was less. And some of the experience from sample preparation showed that the lignin that we received was powder, and we found no indication that lignin 1 and lignin 2 have a melting point within the tested temperatures. Thank you for listening. If you would like to attend our master thesis presentation on Monday next week, you can contact us by mail. Feel free to ask any questions right now or afterward.
Thank you. And we look forward to see more lignin in asphalt in the future. And yes, we do have questions from the chat. How do you make your lignin soluble increasing pH?
Sorry, increasing.
If you open the chat, you can read it also for yourself. Perhaps it's easier to follow it. But how do you make your lignin soluble increasing pH?
We haven't increased the pH, if you mean the pH value.
Of
like we don't have any evidence whether it was soluble or not. It was a powder that we received, and we mixed it with bitumen. So we just we higher the temperature for the samples, and it was how do you make thing?
Okay. And could you, yes, there we have your camera as well. Now we can see you. Thank you. Yeah. So the response is that you do not increase the pH for using it.
No, we didn't do anything like that, and we don't know if it's soluble or not. We could observe after the measurements that when we took out the samples, you could still distinguish the parts of lignin in bitumen.
Right. And why not use directly black liquor and mix that into the bitumen?
Yes, that's a good question. We haven't received the black liquor. We only received the powder that was in solid form.
Yeah. And do you have a guess?
Maybe that would be a better idea to use the black liquor instead.
But perhaps it doesn't give the same or the asked properties. So that could be the why, perhaps.
Yeah, we should investigate it, maybe.
Yeah. And how high temperature can be used for lignin?
Well, we don't know. We can't say that exactly. We just during the RVB measurements, we use temperatures up to 135 Celsius degrees, and we haven't observed any melting point. But this is what we was after. If we would raise the temperature during the sample preparation, like a smoke arise, and that was about 180 Celsius degrees. So somewhere in between, maybe we should stay.
Mm-hmm. Very good. And did you evaluate phase stability, phase separation of the lignin bitumen blends over time?
Nope. At our laboratory, we don't have the equipment to make the chemical analysis. What we did was only measuring mechanical properties. But we were actually wondering, like, if there is a possibility to make something like that, as you suggest, and then measure the mechanical properties.
Yeah, so that could be a continuation.
Yes, exactly.
Yeah. Very good. And which properties or behavior would you recommend to study next, in addition to what you already did?
Well, when you study these properties like low temperature properties and rotting resistance, you can also use a method to see how the samples would age. And then you can get more accurate values, because what we get, it's not a value you can use to count on and make a dimension for a road or a pavement. But if you would use the method with aging, then you could use the values directly.
Very good.
Yeah.
And do you think in the future, will you work, anyone from you, with road construction?
It's a hard question. I mean, like, we can only talk about the lignin that we have tested, and we don't know like what else there is out there. Yes.
And during the studies, the results that you have received, was that what you expected when you started the test of the sample, when you did the setup in the beginning of the year?
And no, actually, we expected that the substance would melt somehow, and but we haven't really seen anything like that. And you know, like when you take a bitumen sample, like bitumen made of petroleum, when you raise the temperature to 50-60 degrees or higher, depending on which type of bitumen it is, it's nearly liquid, and at room temperature it's solid. So we expected that would be the case for lignin, maybe with different interval or something, but you know, we expected that we could achieve some liquid form from lignin.
Very good. And from the chat we have that question: are there any bitumen grades that you could see more compatible with lignin than others?
Yeah, that's a good question, because we only tested the bitumen 70-100. That means that it's like typical medium hard bitumen. If you use softer bitumen and you add up some lignin, then it could behave like 70-100 bitumen. We haven't tested that though, but it's one way to go, like to get softer bitumen and mix it with lignin. But at the same time, you can do the same with granite filler or some other additives, and that doesn't solve the problem, because it's not the granite filler, it's bitumen we need to replace. It's bitumen that it's fossil raw, that it's made from fossil raw materials.
Good, thank you very much. And I hope that you can do the same as Agne. In the chat, write your email addresses for those who want to contact with you. And hope that we will see more of you in the future and more lignin on the roads.
Yeah, thank you.
Thank you for your presentation. Thank you. And David is next on. Are you with us?
Yes, I'm with you.
Yes, great. And you have also done a master thesis within LignoCity, and you also study at Lund University, right?
Yes, I study at Lund University, but I'm at present at RISE in Stockholm. It's a bit of change of scenery.
Yeah, very good. And do you have your camera on as well, so we can see you?
Oh yeah, I can do that.
Yeah.
So.
Thank you. And please go ahead with your presentations, and we see what questions we will receive after it.
Yes, so I've studied the production of PHA from lignin and different, for now, lignin derivatives. It's still quite early in the experiments. I started in the beginning of March. So first go a bit around why lignin. The biggest cost with producing PHA right now, using bacteria, as I am doing, is the cost of the materials. Usually glycerol or glucose is being used, which makes PHA or plastics produced by bacteria 10 times more expensive than ordinary plastics or from fossil fuels. And this is what we're trying to solve by using cheaper starting materials. In this case, lignin, as it's very cheap as of now. So let's also go through something about lignin. A problem with growing things on lignin is that it was evolved specifically to prevent the trees from being attacked by bacteria. It acts antibacterially and it protects due to its complex structure. Most bacteria can't break it down. So that's why we need a special pre-treatment as well for in order for the PHA production to work. This could be pyrolysis, hydrolysis, and different oxidations. This is a step we'll get to later in my experiment, though, as we start so far only done pure aromatic carbons instead of the more complicated networks. And we will work with black liquor in the future as well. The PHA itself is a polypeptide, as you probably heard of. And it's a good alternative to normal plastics because of its biodegradability. However, there are some challenges. The biggest one, in my opinion, is how to extract it from the cells, as the PHA is being produced intracellularly inside the cell instead of extracellularly, which will make this production much easier. So in order to extract the PHA, it is needed to somehow lyse the cells first, and also gives the cells a limited amount they can produce each. But it's a problem we have to deal with some point in the future. So, but then there are also some different kinds of PHA. The most common one is PHB, which means that it has 4 different carbons in this chain, 1, 2, 3, 4. But also PHV, which has 5 different carbons in the same chain. And this is, but the main thing that differentiates these polyesters from normal plastics is the bonding between the polymers. It's an ester bond, which makes it very possible to break down naturally by bacteria. As you saw in the previous picture, could perhaps go back. It breaks down over time. This takes a period of months instead of years, as with normal plastics. However, it's also very stable that's only when it's covered in dirt. In normal fridge or normal storage, it's very stable, which otherwise it wouldn't be a good alternative at all. So now we're going to get into more results so far. In my experiment, we have done with produced PHA using 3 different bacteria. It's Pseudomonas putida, Senecatul, and Odororphy. And so far I've seen good growth on vanillic acid, vanillin, serinic acid, and for 2 different hydrobenzoic acids, which is very promising for the future. However, we started a bit of the analysis of the PHA content, however, but as I said, I started with those analyses this week, so there's no results in from that yet, and the amount of bacteria so far is very low, so that's results for the future. However, as I said, we have good growth as of now, with first ones in P. putida going very good, and glycerol. I use glycerol as well, but that's early experiments. And as you can see, there's also a significant lag phase, which makes it possible, which makes it very likely that some of them having difficulties adapting to the new carbon sources, while, for example, P. putida is the very flexible ones, which, however, this is also on bacteria that previously been grown on tryptosine soy broth, and it's a bit lower lag phase for the bacteria grown on vanillin before, as this changing phase seems to be the biggest factor for the lag phase. And the final growth curves are on a scaled up the experiment a bit. You can see that the lag phase here, the beginning, is substantially lower, which is, I would guess, is due to the fact that we had grown these bacteria on vanillin before starting this bigger growth. We also measured the amount of carbon used. This would be an indication of if they produced PHA or not. And as you can see, the bacteria is grown on vanillic acid has a very high amount before, however, as well as the 4-hydroxybenzoic acid has very high amount of carbohydrates before. However, afterwards, there's a very low amount left, especially considered if you compare with syringic acid, where the drop is lower, and considering the fact that they had about the same optical density, I would say this is an indication that the bacteria grown on syringic acid might not contain as much or no PHA compared to the other batches I grew. And so for the analysis, which I started this week, I'm gonna do it with NMR, if possible, or GCMS. However, I do not have any results yet. They will come in later. Hopefully this month I will get some more results. And I will present this in August. And I finish with this thesis. But that's all for me. Thank you for listening. I saw there were some questions as well.
Thank you, David. And I asked the same question to you as to Luan and Nicola. Did you get the results you expected?
I hadn't really much expectation for this. For the PHA, I am not sure yet. I haven't gotten anything. For bacteria, I wasn't surprised that we grew as well as they did on all media. So, but yeah, as I said, I'm still waiting for the real results.
Yeah, and they are about to come within the next few weeks, or?
Yeah, hopefully I will get next week or this week. I will be able to extract it.
Very good. And you will have a final presentation also?
Yes, but that will be in August.
In August, okay.
So some time left.
Yes. And if someone is interested to follow it, I assume you can also type your email address in the chat for those who want to contact you and get an invite for your final presentation. And was it easy to decide to work on lignin for your master thesis, or how come that you've chosen lignin?
Why lignin? It's a thesis suggestion I saw at RISE, which I found interesting, that they would try to produce PHA from lignin. So I applied for that and got an interview. And then 2 weeks later moved to Stockholm.
Very good. And is it something you can recommend if we have other students listening today that also think about their future master theses?
Yes, I would. It's very interesting. If you're interested in chemistry and especially biology, it's an interesting topic to investigate further.
Yes.
As this is lignin is so common in nature.
Exactly, it is, and
Good.
so many possibilities, and we hope that more people in the future will open their eyes and see all the possibilities, and that we can
Yes.
grow the applications even bigger. So what will you do in the future? You are close to receive your exam, right?
Yes, it's after this, and then I'm not sure. I'm going to have a delayed exchange semester next semester in the Netherlands, but after that, I will graduate and try to find work somewhere, I guess.
Very good. And is it any lignin involved in your exchange studies?
And I don't think so. There was a course in green chemistry, so maybe, but I have a feeling it's not.
No. Very good. I know that Yibing was in as a listener. I asked loud out, is Yibing with us? Because he has been supervising you, right?
Yes, and so is Peter Rette, where I also saw.
Exactly, Peter is also there. So if you're close by and want to turn on your microphones and cameras and say hello, you are free to do so, Peter or Yibing, or both of you.
Hello.
Hi, Peter.
Hi.
How are you?
I'm fine. How are you?
Yeah, not too bad. Good. Master theses. How many have you been supervising during the years?
Oh, don't ask me. I think it's maybe something like 10.
Very good.
But this year I only have 2 students.
Yeah.
David being one of them.
Hi, Yibing.
Yeah, hello everyone. It's Yibing here.
And you've also been supervising a few master theses, among those with David?
Yes, several at the time now.
Yeah, good. And you both look happy, so I guess that you look forward to assist more students in the future also, right?
Yeah, sure. Please with Lignin also.
Yeah. And who is interested in to understand more what you are doing, Peter and Yibing? You have been presenting in the previous webinars. So if our audience want to listen to you speaking, then they need to go to LignoCity and the webpage and find the recordings there, where also this one will be. Yibing, do you want to comment David's master thesis with a sentence or two?
Yes, it's as David already mentioned, it's an interesting topic for sure. So it's also related to the first presentation, Karlstads universities, where they also produce PHA from different raw materials. But lignin is the most challenging things, as David mentioned, is antimicrobial from the native inherent properties. So it's the slowest one you can expect it. So it's really challenging. So we are struggling to prove we have PHA as in the product.
Very good. And Peter, how do you want to comment this master thesis?
Well, it's a very interesting technique, and I think that it could be very interesting results here. And if we could continue with the work afterwards to try to scale it up, it becomes even more interesting. We also have another student who is looking at lignin as additives in PHP plastics, so they're kind of related to each other.
I'm not sure if you saw, but there was a guy who entered in the background.
We heard, we couldn't see him.
Yeah.
Yeah, very good. So good to see you all, even though we work digitally, but we are getting used to it, I think, and we will continue to do so also after the summer. But LignoCity presentations will take some summer holiday, and we will evaluate the webinars held and come back after the summer with more interesting speakers. So we look forward to that. And don't hesitate to contact any of us that you have seen on the screen or are among us. So thank you so much for all presentations for today. And with some minutes left, we give you all time to get a coffee cup before your next digital meeting possibly starts. So thank you so much for today. Happy that you joined us. Thank you for your time, and see you in the future. Bye-bye. Thank you.